Hello, we're doing checkpoint 4.33. Here we have an island 1 mile from the shore, a distance from the cabin. So let's say this is your shore, this is your island, that's 1 mile away. So this is 1 mile away. And then you have a cabin on the shore, along the shore, that's going to be 15 miles from the closest, well, the point closest to the island. So this is 15 miles. And then suppose the visitor swims at a rate of 2.5 miles per hour and runs at a rate of 6 miles per hour. Let X denote the distance from the visitor that the visitor will have to run before swimming. So the idea is that the visitor will run along the shore and at some point will switch to swimming to the island. So the distance over here and some X value, and then swim to the island. All right. So what we're going to want to do is possibly designate this to be an X value. So let this be X distance from the cabin to the point on the shore where this person will stop and start swimming to get to the island. And then they want us to find the time that it takes for the visitor to get to the cabin, to get from the cabin to the island. All right, so we need this distance and this distance. We don't know what this distance is yet. So let's put y here for now. And those are distances. They want to minimize the time, it looks like. So they want to find the function of time. All right. So there's a couple of things that we need to do. We need to convert things in terms of time. But first, let's find this distance y in terms of x. So let us redraw this triangle. This will be a right triangle. And this we know is 1 mile. And this is what we're looking for. And we don't know angles or anything like that, but we do know that if this whole thing was 15 and you ran X miles, then this little small bit is going to be 15 minus X. Okay, so according to Pythagorean's theorem, we're going to get 15 minus x quantity squared plus 1 squared is equal to y squared. So if we want the value of y, y is going to be the square root of that. So let's just rewrite this y as a square root of 1 plus 15 minus x quantity squared. So that's that distance y, and we have distance x. Now these are distances, and we want the time. So let's remember our handy formula: distance equals rate times time, or if we want to do things in terms of time, is going to be distance divided by the rate. And we have rates, I think. We have rate for going along the running part, and we have the rate for the swimming part. All right, so let's write this in terms of time now. So our time, and our time will be a function of x, will be the distance that this person is going to run along the shore. So this will be a distance of x along the shore, and then the rate that this person runs was 6 miles per hour. Okay, so if we want to put units, this will be miles on top divided by miles per hour in the bottom. And then you do the reciprocal, cancel the miles, and this would just be hours, which is the time that we want. So this is just a little bit of a side note. And then the next thing is going to be the y distance, the swimming distance. That's a square root. Oops, this isn't an equal to. This is a plus, because we're adding these two times. Plus 1 plus 15 minus x quantity squared, all under square root. And then the time that that takes, which is going to be 2.5 miles per hour. Okay, and just write this a little bit neater. This will give us 1/6 x plus 1 over 2.5 times the square root of 1 plus 15 minus x quantity squared. Okay. In terms of the domain, I don't think they're asking for the domain, but in terms of the domain, the x value is what we're looking at. It's just going to go between 0 and 15. And you can decide to include that and call it a closed interval, but your answer should be between 0 and 15. All right. So we can pause it here and be done with the checkpoint, but